if you need to do insert, if you need to do delete, then he is our guy. So ultimately, without thinking, everyone use binary search tree, okay? Because they are not the one who program it, okay? They use the library. Now, so binary search tree is the average guy that can do everything with the best possible way on average, right? It has log n, log n, log n, then you can be happy because you do not know what you want to do, okay? Now, of course, its worst case is not different from many others. In worst case, it's O n, O n, O n, O n, all big O order of n, because in its worst case, what it is? It's a linked list. Okay, so in worst case, it degenerates in a linked list. It actually is as bad as a linked list, but the insert and delete is even worse. Okay, but anyhow, we all usually look at this from a perspective. Now, I need to warn you. Okay, of course, in reality, for simple applications, we will still have some special rules. For instance, stack and queue remain to be very useful because of their special property. Just now you see we still use a stack to evaluate expression. But for linked list and array, they usually are used for small amount of data, such as your assignment. Okay. Now for many applications, it's either hash table or binary search tree. Now you can imagine when there is something that is no order, hash table will still win by all the constant times. Okay? But when there is order, which many of the things are product catalog, student ID, right? Everything, then binary search tree will still be the preferred one because hash tables simply do not have any order. Okay? Now, in this case, it is actually to represent the sorted list ADT or even sorted dictionary, sorted set, okay, or ordered set. Now, so in these cases, sorted list ADT is actually an abstract data type of a list. But then, it is actually always sorted. Right? The binary tree is always sorted, right? So rather than using a linked list to represent a list, we actually use a binary search tree to represent a sorted list. It only appears to list as to the user. Okay? But in the behind, okay, we know that it is actually a tree. Now all elements of the list are distinct. Now we can modify the tree rules a bit to accommodate duplicate keys. Okay? Now, it provides a well-balanced performance on all operations. Okay? And it's never slowest in every category and is capable of every operation. Okay? So the cost of a binary tree is that it's much harder to implement for the programmer. Okay? But it's not you. Okay? I assume there's no computer science student here. You simply use the library of the language. And they are very optimized. Okay? They can even handle millions of nodes without trouble. Okay? So thank you, okay, for doing that. Now, so here, we can see here that a tree can be used to implement data type that is not a tree at all. Okay? Now you can implement list. You can implement dictionary. Right? It's just slightly slower. Not n. Okay? It don't even have collision problems. Okay? And it can be sorted, right? So last time we actually talked about oh, time out again. I don't know who think about this, but it's very annoying in a lecture. Believe that I'm not consuming you most of the bandwidth anyway. We're giving a time out to our